Hi everyone, my name is Lakshmi Tulasi. I'm from second year CSCB bearing the roll number 573. So today I'm here to give the operating system seminar on the topic of evaluation of algorithms. So first, before getting into this topic, I want to discuss a little bit about what are different types of algorithms. And there are basically two types of CPU scheduling algorithms, non-preemptive and preemptive. And non-preemptive has first come first serve, SJF, shortest job first, and priority, whereas the preemptive has shortest job first, priority, and round robin. So here we can clearly observe that shortest job first and priority, these algorithms are both non-preemptive and preemptive. So now let's move on to the evaluation of algorithms, our today's topic. So here we can find four different ways in order to evaluate the algorithms, which we can clearly see here, which is deterministic modeling, queuing modeling, simulations, and implementation. So generally, why we evaluate algorithms, why there is a need to evaluate an algorithm? It's because in order to find the best algorithm, in order to find what is best, we evaluate the algorithm. So here we can see that evaluation of algorithms is useful to select the best CPU scheduling algorithm for executing a set of processes. So in order to find what is best, we evaluate the algorithms. And the scheduling algorithms are evaluated based on many parameters or criteria. The most frequently used parameter is average waiting time, which we use in the deterministic modeling. And the algorithm which results in less average waiting time is selected as the best algorithm. The different methods used for evaluating the algorithms are mentioned here. As I told, there are deterministic modeling, queuing modeling, simulations, and implementation. So let's move further and explore each of this algorithm, each of this evaluation model. So what is deterministic modeling? So it is generally nothing but the algorithm which it is the evaluation process or technique in which we consider average waiting time. In this we consider the average waiting time, and we consider certain algorithm which has less average waiting time as the best algorithm in this modeling. So as we mentioned here, if the workload is known for the set of processes, then this method measures or calculates the performance of all algorithms in terms of the average waiting time or some other criteria. So the best algorithm for executing the given set of processes selected based on calculated values. So let's see the advantages and disadvantages of this. It is simple and fast, and it accurately measures the performance. And the disadvantages are it can be used only if the workload is known in advance. So this is about deterministic modeling. We can easily and simply, fastly measure using this deterministic modeling, and it accurately measures the performance. And the disadvantages, as mentioned here, we have to know it can be used, or we have to know the workload in advance in order to use this algorithm. So here we can see the example, a quick small example of deterministic modeling. So here we are seeing processes along with their burst times and arrival times, and we are working out all the algorithms in order to choose the best algorithm among them. So we worked out FCFS, first come first serve, and its average waiting time is 28 milliseconds, and SJF, its average waiting time is 13 milliseconds, and round robin, its average waiting time is 23 milliseconds. So by this we can conclude that SJF as the best algorithm, as it has least average waiting time. As we can see here clearly, it's only 13 milliseconds compared to FCFS, which has 28 milliseconds, and compared to round robin, which has 23 milliseconds. So we are concluding that by deterministic modeling that SJF is the best algorithm as its average waiting time is less. So next, let's move on to the second evaluation technique, which is queuing modeling. So in queuing modeling, we use a special formula here. so which is W equal to n by lambda, in order to evaluate the algorithm and find the best among them. So whereas n is the average number of processes waiting in the queue, lambda is the average arrival rate of processes into the queue, and W is the waiting time of processes. So this above formula is called Little's formula, and we can see the example here. So if the average number of processes in the queue is 14 and 7 processes arrive every second, then the average waiting time is W equal to n value is 14 and lambda value is 7, which is 2. So we can easily calculate the average waiting time by this queuing modeling. Okay, so the disadvantage of this queuing modeling is the results obtained are not accurate, as the values like arrival rate, number of processes in the queue, and so on are assumptions. So this is the disadvantage of queuing modeling. So now let's move on to the third evaluation technique, which is simulations. So in simulations, what we use a special kind of an operator, we can say, I don't know, but a special thing known as random number generator. Okay, so a random number generator generates all the values of processes, burst times, arrival times, and priorities. So based on this values, we take these values as inputs, and based on these values we calculate these values, and we draw the conclusions out of them. Okay, so as we can see here, a program is developed for each scheduling algorithm. A random number in this method, we develop a certain program for each scheduling algorithm. A random number generator is used. The random number generator generates the processes, burst times, arrival times, and priorities. These values are used as inputs for the programs. The programs are executed and the outputs of the programs are printed. So the printed results are then analyzed to select the best algorithm for the specific set of processes. So yeah, here we also have to remember that based on the process we select the algorithm. Okay, so yeah, we use this conclusions, the printed results, in order to draw the conclusions out of the algorithms. Okay, so the disadvantages are, there are 3 disadvantages in simulations. This method is expensive, as programs need to be developed for each algorithm, and it takes more time for developing programs, executing the programs, and analyzing the results, and it requires more storage space. So these are the disadvantages of the simulations. Next, let's move on to the fourth algorithm evaluation technique for algorithms, which is implementation. So in implementation, what we do is we generally develop a program for the algorithm, and we include it in the operating system. We implement it in the operating system, and then we take the user's feedback out of it, and then we consider, or we take the best algorithm, like we choose the best algorithm out of the user's review or feedback. So as we can see here, to evaluate an algorithm, a program is developed for the algorithm and is put into the operating system. The performance of the algorithm is measured by seeing how it works and taking the feedback from the users of the program. So yeah, it is seeing how this algorithm works, and also like how the performance of the algorithm works, and also it's mostly based on the users feedback out of it. So the disadvantages, it also has some disadvantages. As we clearly can see, it is very expensive, as the program for the algorithm needs to be developed and operating system needs to be modified. It needs to be modified every time, and the program for the algorithm needs to be developed every time, and the users don't like the frequent changes in operating system. Of course, they don't like the changes, they don't like the unpredictability, the changes going on all the time in the operating system. It just annoys the user. So yeah, this is everything about the evaluation of algorithms, and based on these 4 techniques we evaluate the algorithms, but it's mostly based on the average waiting time. Okay, So this is everything, and I want to conclude my seminar here. Thank you so much, and